So I think what we're doing today is somewhat a review. John, take off the hood. But it's still what we got to do, right? This is about solving inequalities, right? We've done pretty much everything that at this level that we can do of solving equations. Now we have to solve inequalities. And what do we mean by inequalities? Something like that has these symbols in it, right? What are these symbols called? This is less than, okay? We can't be making mistakes about what's a greater than and what's a less than, okay? If we do, then now's the time to get beyond it, right? It has to be just be instant knowledge, rote memory. That's a less than, that's a greater than, right? What about these bottom two? Right, or equal to, right? Understand that it's the smaller number is on this side that it's pointing to, right? And it's opening up to the bigger number, whether it's, you know, in that direction or in that direction. And the difference between these two on top and these two on the bottom is, you know, if I said 2 is less than 2, that would be false. But if I said 2 is less than or equal to 2, then you say, okay, that's okay, because it includes the or equal to, right? So those are the symbols that we use that we should know. If you have confusion about them, you need to get unconfused. We solve inequalities pretty much just like we solve equations, right? We isolate a variable on one side by doing operations to both sides. And we justify those operations by properties of inequality, the things that we were supposed to have copied for the extra credit homework, right? Addition property of inequality. You can add the same thing to both sides, and you get an equivalent inequality. Subtraction, multiplication, division, you know, they all work pretty much the same way. You know, there's an exception on the multiplication and division that makes it different, right? That's the one thing that we really have to emphasize right there, because the rest of it works the same way as an equation. Now, when it came to the properties of equality, we also had reflexive and symmetric property. So would they make sense if we were talking about inequalities? A reflexive property, if you remember, is something that looks like, I hope I got all of that. You know, reflexive for equations would be that 2 equals 2. Okay. Would it make sense to have a reflexive property of inequality? No. Now, symmetric property is something to say like 2 is less than 3, then can I switch sides of the 3 and the 2? If I switch the inequality, I can, right? And sometimes we will do that, right? So I'm not sure we even have a symmetric property of inequality, but we will take things like x is less than 3 or 3 is greater than x and change it into an x less than 3 if it helps us to understand. And so in a way that is kind of like symmetric. You know, we're changing what's on the left and what's on the right. Okay. So when you solve an inequality, always it's going to be part of it is the graph, right? And a graph of an inequality is the number, right, with an open or closed circle on the number and then shading to one side or the other, right? For x less than 3, you have open circle. Why open and not closed? Because why? Yeah, 3 would not satisfy that inequality, right? 3 is not less than 3. So that's why it's open circle on 3. And then you got to get straight. You know, if there's a most common mistake we're going to make on this, and we'll make them commonly, is which side you shade, right? Which side you shade. And understand that less than on a number line is always to the left. Greater than is always on the right. You know, when I look at that, I think of the x as being the shading. The shading is to the left of 3, like that. Now, another way you can think of it, if it's solved for x on the left, then you can use this like it's an arrow pointing to the shading, right? So in this case, since x is less than 3, shade to the left. That's only because the x is to the left. Now, x is greater than or equal to -1. Now, that's closed circle on -1 because -1 satisfies that inequality. And again, the shading, if it's greater than on the number line, that means to the right. Or if I use this arrow, like an arrow, it's pointing the direction of the shading. Okay, so we've got to get the shading in the right place. Okay. So first problem, Death Valley. The highest temperature recorded in the United States was 134 degrees Fahrenheit at Death Valley, California in 1913. Use only this fact to write and graph an inequality that describes the temperatures in the United States. Okay, so let's see. Our inequality is going to involve a variable. What do you want to call our variable? X, okay. If you said T, that'd be fine, but I'm going to say X equals temperature, right? It's going to involve a 134. The only question would be, what symbol goes in between those? Are temperatures less than, greater than? They're greater than or equal to 134? So temperatures can be 135 and 136 in the United States. How about the other? Temperatures in the United States, since that's the record high temperature, then that means in the United States temperatures are always less than. Should it be or equal to? Sure, I mean, hit 134. We know, we've got a data point. It hit 134. So that would be less than or equal to 134. And if I graph it, because it always says to graph it, then all I really need to show is this number, 134. Should I use open or closed circle? Closed, because it includes or equal to, right? And then I can shade it to the left. Do you understand the shading to the left? Right. Like I said, that's the part that we'll make the most mistakes on. So you go ahead and try to do this one, which is the opposite. So what was the inequality this time? Okay. So the lowest temperature recorded in Antarctica was -129 Fahrenheit at the Russian Vostok Station in 1983. Use only this fact to write and graph an inequality that describes the temperatures in Antarctica. You know, when they say that in Antarctica, do you think that's probably valid for the world? Is there a colder place in the world than Antarctica? I don't know. That could be like the world coldest temperature, recorded temperature. Right? Who knows where you study things like that in science, like Antarctica, and I mean they have stations. Obviously, like they've got this Vostok station somewhere. Is it in the most interior spot, which is probably the coldest? Probably not. It's probably somewhere closer to the edge, right? So that -129, maybe the day that it was -129, it was even colder if you got more interior. But that's just the recorded temperatures. Okay, so we used X again for the variable. And obviously -129 was going to be the number. And what was the symbol in between? Greater than or equal to. Right, and so you graphed it, and I know you had a -129 in it. Was it open or closed circle? And did you shade to the right or to the left? You definitely got to know your right from your left, okay? Is it left or right? To the right, okay? So it should have been shaded to the right. Right, warmer temperatures everywhere else. Now, the next set of problems, they're actually going to give us the graph and ask us to come up with the inequality, right? So they've like in this case, because it's in between the integer values, they've given us the number, negative 6.5. And they didn't give us a variable, but let's just say we'll use x, right? So let's see, it's going to be x. There's going to be a negative 6.5. Should it be or equal to or not or equal to? It's open circle, right? That's open. So it's not going to be an or equal to. Is it greater than or less than? On the number line, greater is to the right, right? So it's shaded to the right, so it's greater than negative 6.5. That's a bad straight line. Okay. How about the second one? Let's see. It's definitely got a 4 in it. It's got an x and it's got a 4. Is it open or closed circle? It's closed, so it will be or equal to. Is it less than or is it greater than? It looks like less than is to the left on the number line. So this is less than or equal to. But again, sometimes, we could say that same thing by saying 4 is greater than or equal to x. Those two say the same thing, right? We switch the sides, but we also switch the direction of the inequality. So I think what happens is sometimes we have to solve for the variable and it's on the right, and it confuses us over which side should I shade when you look at it. But again, you can switch it. We'll call that a symmetric property. And then you can use that inequality symbol like an arrow pointing the way. Right? So you try that one. So what'd you say on the left? So variable x is less than 8. How about the one on the right? Greater than or equal to negative 2.5. Okay, now we get into these properties of inequality. The addition property of inequality is the same property as addition property. Same as the property of equality, which is you can add the same thing to both sides and it doesn't change the inequality. It's still valid. Okay. And you should copy that for that homework. So here's a problem that we have to solve. Solve means isolate the variable on one side of the inequality. Okay, what is with the variable so that that's making it not isolated at this point? The minus 5, right? So how do you cancel a minus 5? You add 5, right? But if you add it to one side, you add it to the other because that's the addition property of inequality. Plus 5. Plus 5. Okay, the negative 5 plus 5 cancel. X is greater than, and what's negative 3.5 plus 5? 9.5. Okay, graph it, right? These always say graph. Most of the time on equations, they don't ask you to graph it, right? Just a point on a line. But for the inequalities, they always say graph it. Right, here's the 1.5. Should I make it an open or closed circle? Open because it's not or equal to. And the shading should go which side? Greater than on a number line means to the right, so shade to the right. Not too bad. So you try that one, the solution. P is less than 4.2. Did everybody get that? Sounds right. Okay, so let's see. Plus, because P is not isolated, it's got a minus 9.2. I have to add 9.2. Add 9.2. And P is less than 4.2. Graph it on a number line. open circle, shaded to the left. Okay. So subtraction property of equality, pretty much what you would think that it is. You can subtract the same thing from both sides, and you get an equivalent inequality, meaning it'll have the same solution. So we can have another tool to isolate. Here's the example. Right? 9 is greater than or equal to x plus 7. X is not isolated because there's a plus 7, so we will subtract 7. Subtract 7. Right? And now it's 2 is greater than or equal to x. Yeah, so when I'm graphing that, right, here's the 2 in the middle. And let's say no controversy over me making a filled in circle on 2. The question becomes, which side are you going to shade? Okay, this is where it might help if you write it, if you flip the sides so that the x is on the left. Right? What would it look like if I flipped the sides of the x and the 2? Yeah, it would flip this 2, so this becomes less than or equal to. And now it's clear. Which side do you shade? Left. Okay, so what do you think is next? You try? Okay. So what do you get? The 0.5? Let's see. 0.5. Y plus 5.5 is greater than 6. Subtract 5.5. Subtract 5.5. Y is greater than 0.5. Okay? Number line. It's got to have a 0.5 in the middle of it. Should I use open or closed circle? Open and shading to the right. And so here's a word problem. You are checking a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weights, W, in pounds that you can add to the bag. So we have to set up an inequality that represents the situation and then solve it. Right? So let's see. What is the limiting number here? It's 50, right? What do we know? The weight of the bag has to be less than or equal to, right? So we know it's going to be a less than or equal to 50. What goes on the other side? Well, W, but W is what? W is the actual weight of the bag. What are we going to do with the 16.8? Yeah, I mean, they say your bag weighs 16.8 pounds. They want to know W is not actually the weight of the bag. It's the weight you can add to the bag, right? So how do I represent the total weight of the bag? W plus 16.8. Right? So now that's giving us the weight you can add to what it already weighs has to be less than or equal to 50. Solve. What step will we take? Yeah, subtract 16.8. Subtract 16.8. And W equals 16.8. So who's got an answer? 33.2. So you can add 33.2 pounds to your bag. Find the errors. What does it look like they messed up on the left that you are never going to do, right? What did they do? Right. They didn't do the same thing to both sides, right? So the property of equality means you had to do the same thing to both sides, and they didn't do it. I mean, -8 was the right thing to do, but you got to do it on both sides. What about this one? Okay, they shaded to the wrong side. Again, that happens when you have the X on the right. We make the mistake more often when the X is on the right. But again, to me, when I think of the X is the shading, right? In this case, the shading, because it's on the open end here, should be to the right of the number. The number is there, so the shading should have been to the right of it. Now, if it helps, you could have written it X is greater than or equal to -3, and then maybe you wouldn't have made the mistake. But, so, you might, if this seems like it could be a problem, you might want to get in the habit of, switching the sides and then determining whether it's right. Or another thing you could do is you can just substitute a number from the number line, right? For example, if I put in -2 here, it would say that -3 is less than or equal to -2. Is that true? Is -3 less than or equal to -2? It is. That means the shading needs to go that way, right? If I try a number over here, is -3 less than or equal to -4? No. So the shading shouldn't be including -4. I mean, this gets into when we were like checking to see whether something could be a solution. That might help you to get the shading in the right place. Because in the end, that is going to be the thing that we make the most mistakes on. What side you do the shading. Okay. I forgot about the field trip. I was thinking, we're going to have a class where I can't give you back the test because the other class still got to take it. So I basically got the whole class, and this lesson is not enough for a whole class. So I came in and I made the next lesson. But now with everybody gone, I think it's probably not the right idea to present 2 lessons and have those people miss 2 lessons. We'll just have to do that next class. I was going to go on to multiplication and division, which, those are the ones that are different than when you solve an equation. And just to kind of foreshadow what we're going to do, how is it different when you multiply or divide when you solve an inequality? Victoria? By what? Yeah, if you multiply or divide by a negative, you have to flip the symbol, right? That's something you don't have to worry about with equations. But that's kind of why, remember when we were solving equations and if we had a variable term on one side and a variable term on the other, we always said move the smaller variable term to the other side because that left a positive coefficient. Well, when you solve inequalities, that makes a big difference because if you create a negative coefficient, you're going to have that issue. And so you try to avoid that. Try to avoid the negative coefficients by doing that. So, multiplication property of equality is that, and division property of equality works the same, right? Because we know multiplication and division are really kind of related to each other. So we'll do that part next class. And we're only going to do the homework from the first section here. I mean, if you want to go ahead just because we don't really have much going on, you're welcome to do it. I'll leave it up there.